Yes. Welcome back. Welcome back. Welcome back. Welcome back. Without wasting our time, we move on to the next theorem. 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 Opening this. Opening this. The next theorem is theorem relating angle at the center and angle at the circumference. Theorem relating angle at the center and angle at the circumference. Angles at the center and circumference. Angle at the center and angle on the circumference. That theorem relates them together. What is that theorem saying? The theorem says that angles formed at the center of a circle is twice the one formed at the circumference of the circle. Meaning, any angle that is formed at the center of a circle is 2 times the one formed at the circumference. Any angle formed at the center of a circle is 2 times the one formed at the circumference. Here is the center, X, Y, Z, P. What the theorem is saying is that angle formed at the center of a circle is 2 times the one formed at the circumference. This is circumference. Remember I said circumference is the total length surrounding a circle. So angle formed here, that is P, is 2 times P here is equal to X. That is what the theorem is saying. X is equal to 2 times P. Likewise, angle Y is also at the center. It is equal to 2 times Z. Angle at the center is 2 times the one at the circumference. So X is equal to 2 times P, Y is equal to 2 times Z. That means if P is 20 degrees, X will be 2 times 20, 40 degrees. If Y is 150 degrees, Z will be 150 divided by 2, because 2 times Z is equal to Y. Very simple. Olu has 200 naira, or let me say Olu has 2 times what Ade has. Olu has 2 times what Ade has. If Ade have 200, Olu will have 200 divided by 2. I hope you get the analysis. The same thing here. 2 times Z is equal to Y. So if Y is 150, automatically Z will be 150 divided by 2. Quite simple. Very simple and easy. For instance now, what if a question comes? Example, find x, y, and p if this place is 70 degrees. Shall we? Can we try? Can we try? The light ray, hope we can see now. 70 degrees at the circumference. What will be the value of x, y, and p? Shall we? To apply this, we said angle at the center is 2 times the one at the circumference. Angle at the center are 2 angles. Remember, there are 2 angles formed at the center. There is angle x, then there is angle y. Angle x is called obtuse angle. What is an obtuse angle? Quickly. An obtuse angle is an angle that is less than 180. Greater than 90, less than 180. Any angle that is greater than 90 degrees and less than 180 is an obtuse angle. So angle x is an obtuse angle. While angle y is a reflex angle. What is a reflex angle? A reflex angle is an angle greater than 180 but less than 360 degrees. That is clear. And we said they are both formed at the center automatically. First thing first, x plus y must be equal to 360 degrees. These are theorems from primary school. Angle at a point. Angle at a point. I hope it's clear. So if x and y added together gives 360 degrees, let me write the reason. Angles at a point. Just as we said, sum of angles on a straight line is 180 automatically. Angles at a point is also equal to 360 when you add them together. So what is y? From this theorem, angle at the center is 2 times the one at the circumference. So at the circumference, 70 degrees. Then what is y? Automatically, y will be equal to 2 times 70 degrees, giving me 140 degrees. If that is the case, what is angle x? What is angle x? What is angle x? X, we said, added to y must give 360 degrees. What is x? So x plus 140 must be equal to 360 degrees. X is equal to 360 degrees minus 140 degrees. X is equal to x is equal to 220 degrees. If x is 220 degrees, what is p? What is p? We said x is 2 times p. Angle at the center is equal to 2 times the one at the circumference. Automatically, x is equal to 2 times p. P will be equal to x all over 2. X is 220 degrees divided by 2. P will be equal to 110 degrees. That's it. That is the application of that theorem. Quite simple. We're on theorem number 4. Can we move on? Yes. I'm moving on. Theorem number 4. I'm moving on. Theorem number 5. Theorem number 4 deals with cyclic quadrilateral. Cyclic quadrilateral. First thing first, what is a cyclic quadrilateral? A cyclic quadrilateral is a four-sided shape drawn inside a circle. A four-sided shape drawn inside a circle, meaning a four-sided shape where the vertices of the shape is touching the circumference of the circle. What is the theorem now saying? Well, I said a cyclic quadrilateral is any four-sided shape that touches the circumference of the circle. This is a cyclic quadrilateral. This is a typical example of cyclic quadrilateral. The four vertices, any four-sided shape inside the circle is a cyclic quadrilateral. It could be drawn anyhow. It could be drawn anyhow. It could be drawn anyhow. That's a cyclic quadrilateral. So there is a theorem talking about them too. There's a theorem talking about them. So when you see all those lines and the circles drawn, calm down. Sorry about that. The board is trying to protest. So the theorem about cyclic quadrilateral is saying angles, opposite angles of a cyclic quadrilateral opposite angles of a cyclic quadrilateral are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. That is theorem number 4. Meaning, if I have a cyclic quadrilateral this way, here is the center. The angle here and the angle here, let's call this angle A, angle B, angle C, angle D. What the theorem is saying is that A plus angle A plus angle C must be equal to 180. Those are supplementary angles. Supplementary angles are angles adding up to 180. Any two angles that add up to 180 are said to be supplementary. So angle A is supplementary to angle to angle C rather. So the opposite angles in a cyclic quadrilateral are supplementary, 180 degrees. Likewise, B plus D are also supplementary. Supplementary angles. This should be theorem number 5. We did theorem number 4 already. Theorem number 5. That is cyclic quadrilateral. Opposite angles of cyclic quadrilateral are supplementary, meaning angle here plus angle here, when you add them together, it gives you 180. Angle here plus angle here, when you add them together, it gives you 180. Quite simple. All we need is just application of theorem. Nothing more. Nothing more. Shall we? Shall we? سبحانك يا ربي سبحانك Yes, let's look at this example. And how to apply that theorem. Let's look at this example. Find the lettered angles in the diagram below. Find the lettered angles in the following diagram below. Yes. Find the lettered angles in the diagram below. Find the lettered angle in the diagrams below. Let me zoom that so that we can see. Yes. In there, I have angle 20 degrees, angle 150. Then I have A, B, C, D, and E. Yes. A, B, C, D, and E. Can we make an attempt? Can we make an attempt? Yes. A, B, C, D, and E. The first angle to look at there, if you go by that, the first angle to look at there is angle A. Look at angle A and angle 150 degrees. Angle A and angle 150 degrees. If you look well, you will see that they are opposite angles of a cyclic quadrilateral. Yes. Four-sided shape inside a circle. That's a cyclic quadrilateral. So the four of them are on the circumference of the circle. What do we then do? We then go back and say A plus 150 degrees is equal to 180 degrees. Why? Why? That is opposite angles of a cyclic quadrilateral. So what is A then? A will be equal to 180 degrees minus 150 degrees. A is 30 degrees. That's all. Found A. We move on. We move on. We move on. What is B? We don't know yet. But look at this triangle. We can find E, we can find C. Is that not? Yes. Yes. We can find E, we can find C. If you look at E and C, what do we do? Look at angle E, angle 20 degrees and angle 150. What are they? They are inside a triangle. So we'll go back and say 20 degrees plus 150 degrees plus E is equal to 180 degrees. 20 plus 150, 170. Why do we have to do this? Because they are sum of angles in a triangle. So 170 plus E is equal to 180. E is 180 minus 170. E is 10 degrees. If E is 10 degrees, what is C? Look at angle E and angle C. They are on a straight line. So we'll go ahead and say E plus C is angle on a straight line. Why? They are equal to 180. So sum of angles on a straight line. Let me on a straight line. You must state these reasons. You don't just assume. Especially when you are doing this in the theory, you don't just assume. You must put those reasons why you are taking those assumptions. It must be stated so as to score your full marks in the exam. In the objective, nobody wants to see the reasons, just get the answer. But in the theory, you must state all these reasons. Very important. So E is 10 degrees plus C is equal to 180. Then C is 180 minus 10 degrees. C is 170 degrees. We found A, C, E. We need D. We need D. We need D and B. First and foremost, here, what parts can I clean? What parts can I clean? Let me clean the upper part here. If I clean the upper part here, then we can say, look at angle D plus 20. It must be equal to angle B. Why? Why? It must be equal because the angle here and the angle here are supplementary. Angles adding up to 180. So, what is angle D? From this point, that question did not give us sufficient information for us to be able to find D or B. Why? Because here there is no information as to what B will be, as to what D will be. If, for instance, we have found the value of D, we're able to substitute and get B. Or if they give us the angle of D, we'll be able to substitute and get D. Let's assume B is given to us as, what is angle? I have 150. What is A? 30. Okay? Let's assume this is 70 degrees. If that is 70 from the question, if that has been supplied from the beginning, so this would have been D plus 20. Did I say D plus 20 is B? No, that is wrong. It should have been D plus 20 plus B is 180. Sum of opposite angles of a cyclic quadrilateral. So D plus B, D plus 20 plus 70 must be equal to 180. So D plus 20, D plus 90 is equals to 180 degrees. Automatically, D would have been 180 degrees minus 90 degrees. D will be 90 degrees. That's how to apply the theorem number 5. That's how to apply theorem number 5. That's how to apply theorem number 5. Moving on. Moving on. Moving on. Moving on. Moving on to theorem number 6. 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 Theorem number 6 talks about tangent to a circle. What is tangent to a circle? Quickly. Tangent to a circle is any line touching a circle externally on the circumference. Any line that touches a circle externally on the circumference. For instance, I have a circle, then I have a line. I have a line touching it externally. That line is tangent to this circle. We could have several tangents to a circle. That's another tangent. We could have several tangents to a circle. That's another tangent. These are lines that touch a circle externally. That line, those are tangents to a circle. So there is a theorem relating to that in circle geometry. What does that theorem say? The theorem says any line or angle formed between the tangent to a circle and a chord from the circle are equal. What does it mean? Any angle formed between a tangent to a circle and the circle is equal to any angle formed in alternate segments of the circle. That is theorem number 6. Any angle formed between a tangent to a circle and the circle is equal to any angle formed in alternate segments in the circle. If I have a circle, then I have a tangent. That's a tangent to that circle. Then I have a line. That's a chord. Here's the center of the circle. Here's a chord. Here's a tangent to the circle. What the theorem is saying is that the angle formed here is equal to angle formed here. Because this line has divided this circle into two chords. Into two segments rather. The minor segment and the major segment. So angle formed here must be automatically equal to angle formed down here. That's it. That is what the theorem is saying. Likewise, I can say angle formed here is also equal to angle formed here. This is another segment. From here, another segment here. So angle here is equal to angle here. If here is A, here is also A. If here is B, here is also B. That is what that theorem is talking about. Let's see example. An example says, find the letter angle in the diagram below. Yes. Find the letter angles in the diagram below. Hope you can see. Yes, that's the diagram. Find the letter angles in the diagram below. As you can see there, I have angle C, angle 20 degrees A, 60 degrees, and B. Quite simple. Quite simple. If you look at it very well, if you've been following us from the beginning, you would realize that, look at angle A and angle 20. If you look at it very well and you've been following, you realize that angle A and angle 20 are in alternate segments. Theorem number 2 talked about them. So automatically, the first thing first, A is equal to 20 degrees. That is angles in alternate segments. That is the first assumption. Again, from the theorem we just treated, we said angle formed between the tangent to a circle and a chord is equal to angle formed in alternate segments. Look at angle B and angle 20. What can you talk about them? Angle B and angle 20. If you look at them very well, you would realize again also that angle B also is equal to 20 degrees. Why? The same reason. Angles in alternate segments. The same reason. Angle formed between tangent and a chord is equal to angle formed in an alternate segment. That's it. Haven't found B. Haven't found A. What is then C? What is then C? Look at that angle. From there you have angle A, angle 60, then angle C. If you look at them well, you realize that they are angles formed in a circle. Angles formed in a triangle rather. So I can say angle A plus C plus 60 is equal to 180 degrees. Why? Sum of angles in a triangle. So what is A? We said A is 20. What is C? We don't know. Then 60 degrees is equal to 180 degrees. C plus 80 degrees is equal to 180. C is 180 degrees minus 80 degrees. C is 100 degrees. Quite simple. Quite simple. Just application of theorems. Just application of theorems. Just application of theorems. Just application of theorems. Nothing more. Just application of theorems. Nothing more. That is theorem number 6. And to cap it for today, we'll be going for the last theorem of the circle geometry of the 7 theorems we talked about. Moving on, theorem number 7. Theorem number 7. Theorem number 7. Theorem number 7, which is the last of the circle theorems for today. Theorem number 7 is simply saying it's also related to tangent to a circle. It's also related to tangent to a circle. It states that if two tangents to a circle are drawn from the same spot away from the circle, if two tangents to a circle are drawn from the same spot away from the circle and a line joins them, at their points of contact with the circle, then an isosceles triangle is formed. That is what the seventh theorem is saying. If two tangents to a circle are drawn from the same spot away from the circle, and a line joins them at their points of contact with the circle, then an isosceles triangle is formed. What does it mean? It simply means if you have a circle and you choose a point to draw the tangent to a circle this way, another tangent this way. At the point where the two tangents meet the circle, a line is now drawn to join them. What the law is simply saying is that this side and this side will be equal. Meaning, if this is point A, point B, point C, then triangle ABC will be an isosceles triangle. What is an isosceles triangle? An isosceles triangle is a triangle that has two opposite sides equal and the base angles equal. Meaning, the angle here will be equal to the angle here. That is what it simply means. And that is what the seventh theorem is talking about. That is what the seventh theorem is talking about. If two tangents to a circle are drawn from the same spot away from the circle, and a line joins them at their points of contact with the circle, then an isosceles triangle is formed. That is what the theorem is saying. Meaning, the line from here to here is also equal to here. Meaning, line AB must be equal to line AC. If that is the case, that forms an isosceles triangle, then angle B must be equal to angle C. That is what seventh theorem is talking about. Quite easy, quite easy, quite easy. Let's have an example on this and we'll wrap it up for today. Let's have an example on this and we'll wrap it up for today. I don't want to clean this. Let me clean the theorem itself. If I do this using this same diagram, if this is the center of the circle, yes, if this is the center of the circle, what is A? Here is 50 degrees. Here is 62 degrees. So I'm looking for angle AD okay. Yes. Find the lettered angle. In the diagram below. Find the lettered angle in the diagram below. What do we do? Let me zoom that. Yes, that's what we have. I have angle B, angle C, angle D, and angle A. What will be the value of A, B, C, and D? The key to this question is very simple, quite simple. Look at angle 62 and angle B. If you follow what we've been doing all along, we said angle formed at the center is 2 times the one formed at the circumference. So here is angle 62 formed at the circumference, and B is angle formed at the center. Automatically, what that means is that B will be equal to 62 degrees multiplied by 2. That is, angle at center is equal to 2 times angle at circumference. There you go. So B will be 2 times 62. That is 124 degrees. Quite easily done. I also said angle at a point is equal to 360. That means angle D and angle B are angle at a point, meaning D plus B is equal to 360 degrees. That is sum of angles at a point. So if angle B is 124 degrees, then angle D is what? That means D plus 124 degrees is equal to 360 degrees. D is 360 degrees minus 124 degrees. D is 360 minus 124. 360 minus 124. 6, 3, that is 236 degrees. That is angle D. Now we need angle A and angle C. How do we go about it? Now look at it. They said O is the center of the circle. If O is the center of the circle, automatically, that means this line and this line are 2 radii. Whenever we have radii equal to radii, triangle here is what? An isosceles triangle. If it's an isosceles triangle, then we can find A. That means A here will also be equal to A here. Is that not? Yes. That means, where am I cleaning? Where am I cleaning? Okay. Let me manage here. Automatically, B plus A is equal to 180 degrees. Why? Why? Sum of angles in a triangle. This angle plus this angle plus this angle is 180 degrees. So that means B we said is what? 124 degrees. So 124 degrees plus A is equal to 180 degrees. That means 124 degrees plus 2A is 180 degrees. 2A is 180 degrees minus 124 degrees. 2A is equal to 236 degrees. 180 minus 124. That should be 56 degrees. So automatically, let's continue here. 2A is equals to, that means A is equals to 56 degrees all over 2. 2 here, 1, 2 here, 28 degrees. A is equals to 28 degrees. If A is 28 degrees, what is C? Remember, C is from here down to here. Now let's go back to that theorem. Theorem says any two tangents from the same point touching a circle must be what? an isosceles triangle. If it's an isosceles triangle, that means angle here and angle here must be equal. So if this place is C, this place is also C. Isn't it? Yes. That means C plus C plus 50 degrees is 180 degrees. 2C plus 50 degrees is 180 degrees. 2C is equals to 180 minus 50 degrees. 2C is equals to 130 degrees. So what is C? C will be 130 degrees all over 2. C is 65 degrees. C is 65 degrees. So if C is 65 degrees, and we said A is what? Where is A? We found A to be 28 degrees. So automatically, what is the total angle here? A is 28. C is here. This angle. That means the total angle we are talking about is 28 plus this. So the angle we need as C will then be equal to 28 degrees plus 65 degrees. The total angle there should be 93 degrees. That is all the angle we need. And that is that about circle theorem. Ladies and gentlemen, at this point in time, we've quite exhausted all the theorems about circle geometry. I've said it. The only success you can get in this topic is when you master the entire 7 theorems. When you know these theorems, then you'll be able to study each question and apply the theorems as they apply to each question. At this point in time, we've spent quite over close to 2 hours now. So at this point in time, we're going to be closing the class for today. I hope you have had a very wonderful time with us, an exciting time with us. As I have enjoyed myself, I hope you have been able to enjoy yourself again. At this point, I'll be signing out and hoping and praying that God Almighty will protect us and be with us till we meet again next week. Bye for now.